Okay, welcome to the final sprint. We have only 4 contestants and we are only 10 minutes late, or 15, which for the national average means pretty much we're significantly ahead of time. This session is about, you could say, horizontal elements that are necessary for the development. Initially, we will talk about capacities and infrastructures, which are absolutely necessary. I have myself experienced a lot in the last 10 to 15 years how much of a difference it makes if you have some support infrastructures and some collaborations that you can use to make your marine projects go. And the other element is even worse of a challenge. What if these projects have success? Then they need a supply chain to quickly build all the projects. So as a first speaker, I call Marco from WavEC, and in his function of part of the CoLAB, of the collaborative laboratory, he will explain how Portugal tries to bundle its capacities now in this sector. Marco.
Okay, my name is Marco Alves. I'm the member of the board of directors of Plus Atlantic. Plus Atlantic is a new organization focused on scientific challenges of the Atlantic system. But before sharing some information about the creation of this new organization, I would like to share with you some ideas on the framework that is to some extent the rationale behind the creation of this new organization. And the first one is basically the knowledge that the Atlantic has a very strong influence over the global Earth, with significant scientific challenges. Those include space, ocean, atmosphere, data, and those scientific challenges are very complex and path-dependent. Another aspect is that there is no single organization prepared to tackle those scientific challenges today in a very appropriate and comprehensive way. There is also there is a global coalition and a trend that has been formed not only in Portugal but a bit all around Europe and probably all around the world. A coalition being formed to identify and tackle these scientific challenges. Moreover, there is the need for an integrated approach from deep sea to space, allowing for a better understanding of the interactions over the ocean. And another point deeply related to the previous one is that there's a need to bring together experts on ocean, space, climate, atmosphere, that traditionally are not very, I may say to some extent, are not very keen to work in straight collaboration. And finally, there is the need to leverage a specific set of assets to improve the knowledge and better understanding the Atlantic Ocean. So this is basically the framework for the creation of this new institution, this new organization in Portugal. And so in this framework we have a very clear vision. I believe that is quite ambitious, but it's always good to start from with a lot of ambition. And this vision is basically to be a leading provider of innovative scientific and commercial services towards a better understanding of the dynamics of the Atlantic Ocean, again from deep sea to space, and enhance the sustainability exploration of resources. And this is basically our vision. Our mission is basically to develop infrastructures and capabilities to provide sustainable and holistic, and here the word holistic is very important, holistic solutions on the Atlantic system through new data, new information that will allow for a better exploration and exploitation of the Atlantic resources. So, okay, this is basically to explain the framework and what are our guidelines in this process of creation of this new institution. About funding and the funding structure, this is basically a very simple structure. We are planning to have a 1/3 is national public financing. Another third is competitive financing. I mean, European or national at European and national level. I'm here thinking on H2020 projects, Portugal 2020 also, and we are also foresee some involvement in the next framework program, the Horizon Europe. And the last third is basically rendering services to industry. Of course, this is not a very static structure. We plan to increase as much as possible the services to industry to better fill the gap between academia and industry to some extent. And from another side, there is a very small slice that is not considered here, that is basically related to the some fees that the associators will pay us. Okay, this is the financial structure. Now a bit on the implementation path. So the implementation is split in two main phases. The phase one is launched from 2018, so from this year, and will take 4 or 5 years. And here we define the ownership structure, and basically the ownership structure is a private association held by Portuguese industry, R&D centers, and public institutions. The focus on the is to some extent we can see the Plaza Atlantic as a consulting organization with strong R&D background, with highly qualified and multidisciplinary team. Important that for the next 4 or 5 years we are looking into employ directly employment about between 40 and 60 people, of which 20 will have PhDs. We plan to have to work in collaboration with universities, as I said, R&D centers, industry, and national authorities. Very important is the infrastructures we plan to manage. Of course, this is still on the table. There's a lot of discussion on this topic. The infrastructures that most likely we will manage is the Santa Maria Antenna, test sites of Aguçadora and Sines, the Viana do Castelo pilot zone for different TRLs, higher TRLs, and will be linked with the Peniche Ocean Technology Center. Finally, extensive partnership, which will be built on the partnerships that our associators have in place already. The next implementation stage or phase is basically the consolidation. It will start around 2023. It will take 5-6 years, and the main difference from the first phase is basically that we will increase or enlarge the number of people working directly to the CoLAB Plaza Atlantic. People that will be, the number will be between 80 and 120 people, and of which about 40 will have PhDs. The other and the most important modification is in the infrastructure side is basically the satellites. We are planning to have a satellite constellation, a subsea constellation, and an ocean multipurpose platform. This is, I will speed up, this is basically to share with you the interest that has been put on the Plaza Atlantic from shareholders and stakeholders. We can show you more detail all these institutions later. And now I would like to share with you some information on how we fit in the value chain. And as I said, we see CoLAB on the service, on rendering services that basically are the combination, and this combination allow us to build value on top of the services that our associates from universities, from our research centers, from industry, etc., they produce already. So the idea is to build something and create value on top of the services they are able to provide already, and to add value through this way. The end users will be scientific users, commercial users, and very important to highlight here the air center, because the plan here is to look into the air center or look into the CoLAB as the node, the Portuguese node of connection, or at least the main node to connect Portugal with the air center. Okay, so this is the normal path, let's say. We also foresee the opposite direction, and the opposite direction means like we will be able to identify the needs on the users, the needs, and take those needs to those of our associates that are more skilled to solve these problems. Okay? So, our business approach basically relies in three main layers, let's say. The first one is the airborne constellation, and these basically drones, many different type of drones. The other one is the spaceborne constellation with nano and micro satellites. And the last one is the seaborne constellation, composed by oceanographic buoys, ROVs, etc. So the idea here is to combine information, and combine information is mostly combine data between these three layers in order to produce and to create added value services grounded on an integrated approach, as I said, from deep sea, from the sea-borne layer to space, or the space-borne layer. And those services are based on mostly data analytics, data science, data treatment, also holistic and disruptive concepts. We can look into the services that our associates are able to provide and reshape those services, adding values, combine those services, and approach clients with a much wider range of services. And also we are looking into new, I may say, new disruptive business models. And the idea is to support complex and non-standard activities. It is not completely true, it's to support complex, standard and non-standard activities. And those include marine renewable energies, for instance, offshore aquaculture, deep sea mining activities, earth, atmosphere and climate issues, metocean for offshore activities, and many, many others. So to conclude, and probably this presentation was too much focus on services, business, market business services, but the idea and the overall objectives is a bit wider than that. So one very important key for us is the employment, create highly qualified direct and indirectly employment. The value, as I said, create a sustainable service portfolio for scientific and commercial users. Mobilize, and this is very key, bring together scientists, research centers, industry, market agents around a common strategy to develop this knowledge focus on the Atlantic Ocean. Broaden, engage new agents of innovation all over the value chain, not in a particular slice of it, but in all the value chain, providing opportunities to bring new ideas, and work on the incubation and acceleration of these ideas. And the last one is probably the most important one. I believe that this one is key in all this process, is basically engage everyone to foster a deep understanding of the ocean, because this is to some extent the most important rationale behind the creation of this CoLAB Plus Atlantic. Okay, so this was my presentation. I think I managed to do it in 15 minutes for the first time in my life.
Explain us what the Air Center is about.
Okay, so thank you very much. Thank you for inviting to me to be here today with you. I'm going to try to explain a bit what is the Air Center. So the Air Center is a multinational initiative focusing in the Atlantic in order to connect different countries and to connect the nodes of different countries in order to strengthen the collaboration between these countries and these nodes in the Atlantic space. So you all know all known what is happening in the Baltic, for example, or what is happening in the Mediterranean, where a lot of activity is going on, a lot of collaboration in relation with blue growth, with exchange of information in terms of observation or exchange of information about coastal management, touristic activities, all of these kind of things. So I think that could be done in the Atlantic. Of course, it requires some time. It requires organization between the countries, but that is what the Air Center is trying to do. So by now, as you see, there are several countries already involved. This initiative has been led by Portugal. Spain is following it. And other countries like Cape Verde, Nigeria, Sao Tome, Angola, Uruguay are already involved, and other countries like, for example, UK, India, or Argentina are acting as observers, and others as signatory. So also within these countries, already we have several nodes. The reason that I'm here is because in Spain, Plocan is this node, the national node for the Air Center. But as has been said before, in Portugal we have, for example, CoLAB and other centers. So we are in a process of moving fast and doing this coalescence process of different countries and different nodes in order to create this space for collaboration. I put just some words in here that I like from inside of the mission of what is the Air Center is doing. Is sharing information, is integrating information, is connecting knowledge, creating a space where the technology, the capacities are used in order to provide a high value at the local level, but also at a global level. So in relation with the thematic areas, so as has been said before, we are working with from atmosphere to ocean, climate, energy, data, and so on. Later on, we are going to go in much more detail in relation with the main thematic priorities. But I think that in this figure, you can have this integration between ocean, climate, and energy. These focusing in the Atlantic area. That will be the main focus for the Air Center. So what are the distinctive features of the Air Center? So what is important is that we are going to try to use what is in place, the infrastructures that are in place. So the important thing is just connecting these infrastructures. In the future, of course, we can try to cluster these kind of infrastructures or try to look for gaps that are in there. But at the very beginning, at this stage, what is important is just put all of these infrastructures working together. So it's going to be a knowledge-driven organization. The structure should be lean because we have to be agile. We have to optimize as I say before, the existing infrastructures and the labs. And for us, it's quite important connecting the coastal areas in the Atlantic area. So also the islands and the coastal remote areas that sometimes are a problem. In here could have a special value as a living labs for new technologies. It has been shown before, for example, in the marine energy issues. Instead of being a problem, could be an opportunity for develop early stage of certain technologies, like marine energy, for example. So will be an open space for collaboration. So, of course, it's inspired by the 2030 agenda. And we are going to work, focus on these objectives. It will be very important for us. All of the activities that are going to happen in Portugal during the next years and has been presented this morning, for example, is going to be very important for us to work together with the decade of the oceans. So in order to implement, to help them to implement the actions, or working together, for example, with the Belém Statement in order to help them to implement the actions that they are going to promote. So that is important. I'm not going to be much more detailed because otherwise the time will be short. So this is the main areas that the Air Center is going to target. As has been said by the previous speaker, we are going to focus mainly on marine resources and biodiversity, healthy oceans, integration from the space to deep ocean, climate change, mitigation and adaptation. That will be central activities that the Air Center is going to focus. The sustainable energy systems, and also data science, artificial intelligence, and learning systems and oceans. Again, I would like to point out the central role of the islands, and especially the fact that the Azores is going to be the center of the center of this network. And here we have some examples of projects that the Air Center is focusing in relation with Atlantic data cubes, for example, or supercomputation as an example of supercomputing. We are trying to get the resources that are already available from the supercomputer centers and share these resources in an Atlantic system for access for supercomputing access to the countries and the researchers that will need that. So in here, well, this is the example that I was trying to show. That is quite important because sometimes the resources like satellites or supercomputing, only a few countries and a few institutions of a few entities can use it. Now we are going to share and have provide access to the Atlantic nodes of these resources. So that's other kind of example of projects in relation with, for example, detection of tsunamis or projects in relation with climatic change. I'm going to just use another example of the Markaratland project. Well, this is coming later. This is an example of sensors and observation. Of course, the observation in the Atlantic cannot be done by a single country. It has to be a shared task, and all the countries have to work together and to implement actions together in order to share their resources, for example, vessels or fixed station or drifters or whatever other observation platforms, or also for the observation of the biodiversity. So all of these activities have to be organized and have to be worked in a shared way. This is another kind of project, for example, the observation of the dust coming from the Sahara area. So again, in order to look at the models and to the quantification and to look at the impact of these inputs from the atmosphere to the ocean, we have to have different networks of observation. So the collaboration of these different test sites and sampling places could provide a much bigger impact and picture of what is really happening in the Atlantic Ocean. It will be the same, for example, if we are looking to pollutants or if we are looking to the plastics, for example. We need the collaboration and working together and this integrated network that the Air Center can provide. So the same thing for issues related with climatic change or biodiversity. That is one of the initiatives, for example, that we have been applied for. The European Union is already spending hundreds of millions in the Micronesian area as an Interreg programs. A lot of this activity is going on in the direction of the blue growth activities, but at the same time, there's a Caribbean program that is doing the same. Both they have a mandate to collaborate with the neighborhoods, with the countries that are already there. But at the same time, we have to put in contact the result, the researchers, the technologies that are developed in these two programs. So I think that it's important to create these links. That is where the Air Center came in and produced these contacts and also produce added value in order to look for further opportunities and exploit these relations. At the end of the day, we have to create a larger community. We have to create much more interactions between us. Sometimes the people think what the technologies and what the tendencies are developed in the cities and not in the small town. It's not because in the cities the people will be much more clever. It's because there is much more interaction and there is much more size. So that's the size in the Atlantic is what the Air Center is trying to promote, and also these interactions, these transatlantic interactions. So there is many other areas of activities where the people from the Air Center is already working with, for example, with the Marine Biodiversity Observing Network, with Blue Planet, Future Airs. So there's already projects that are already going with the Penn State University, for example. And here we have the research agenda. So if later on you are interested, I could provide you much more detail of what is happening in these different areas and who is driving these areas and the work plan that is inside of that and the projects that are being prepared. So yes, it's a picture of the organizations that we are already working with, and this is some more. Like WatchE, for example, the infrastructures, the European infrastructures like WatchE, like ENSO, for example, or other more or the relation with biodiversity are important, also important milestones. You're going to have the slides, so later on you can also look at the different organizations and funding agencies, innovation agencies, and research infrastructures that we are working with. And yes, for the next year, it is important that all of these collaboration programs that already have been signed, this memorandum of understanding, these projects that already has started, it is important to consolidate and enlarge the number of users, the number of nodes in the region, and also consolidate this agenda according with the needs of the countries. So I'm not going to extend very much on that. You are going to hear a lot of from us during the next years, and if you are interested in incorporating with this space, we can talk later. Thank you very much.
Marco wants to be in a few years. They already went a step further. So Alexander, please.
Good afternoon. Well done for making it to the last session of the day. So I'm going to talk a little bit about how the Offshore Renewable Energy Catapult delivers innovation. So what we are, how we do it. Talk a little bit about some of our technology support, and then I think we've heard an awful lot about technology today, so I want to also go into a little bit about some of the less technological things we do to support commercialization of innovation as well. And it was really good to hear from Marco about Plus Atlantic, because the funding model and things like that are very, very similar between a Catapult Center and these CoLABs. So we have 10 Catapult centres across the United Kingdom, all designed to fill a gap. So we have world-leading universities and academic institutions providing cutting-edge research, and we have some excellent businesses, but there was an innovation gap that prevented new technologies from reaching commercialisation and delivering economic benefit. And so the Catapult network was set up to try and address this hole and support innovation to move from academic level up to an industrial level. So this slide quite nicely summarizes how we work with industry. So we work with the large device manufacturers, site developers, and site operators to understand what challenges they have. And then we work with them to translate those challenges down through the supply chain towards researchers and innovators who may have solutions. And then using our engineering expertise and our test and demonstration facilities, we can support those innovators and researchers to solve those challenges and deliver improvements for the industry as a whole. So I think risk is really important to talk about in all this as well. So risk and its perception for any industry that has a large amount of capital involved, the presence or the perceived presence of risk will increase costs dramatically. And so ultimately we need to, as an organization, de-risk the industry, de-risk innovation, and help investors and adopters of those technologies to feel more comfortable. And so a crucial part of that is testing and demonstrating and validating new technology. And so we operate a unique set of facilities focused on component testing for offshore renewable energy. So on the wind side, we can test blades up to 100 meters long, both statically and dynamically. Power trains up to 15 megawatts. We can apply up to 6 degrees of freedom to them so that they undergo conditions that they might see in an operational environment. We test high voltage equipment. So we've tested the next generation of 66 kV array cables. And we've recently acquired a dynamic cable test rig for floating structures, where we can simultaneously test them in the wet, thermally, electrically, and mechanically to ensure that they're going to be able to survive the rigorous conditions they'll be exposed to on a project. And in recent years as well, we've been using our facilities in a slightly more innovative way to test and validate O&M technologies, with robotics being a key part of this going forwards. As we try and reduce risk and cost within the industry. So a nice example in the tidal sector in particular, this is our 3 megawatt drivetrain test facility, and it's the test piece on it there is CMEC Atlantis's 1.5 megawatt nacelle from a couple of years ago. So this really helped them to de-risk the introduction of this drivetrain before deploying it in the Maygen project just off Orkney in Scotland. But like I said, technology test and demonstration is just one aspect of what we do. And whilst it is vitally important, there is lots more that we can do to support industry and supply chain as a whole. So I've already mentioned innovation challenges and understanding what the market requires. But we can then benchmark those technologies against competitors and to help investors and adopters understand what level of technology might be achieving. And then, as I'm sure many of you will know, funding is a perennial barrier to innovation. And so we work with companies to identify and partner on R&D grant funding applications to support technology development that way. And then lastly, we work with them to commercialize those technologies as well. And this is becoming increasingly important. So this might be working with our network of private investors to help identify that next step of commercialization support. Developing the business case through to understanding the cost-benefit analysis of using a particular technology, or even just the basics of helping them to understand what can actually be quite a complex market. And so our analysis and insights team that we have at the Catapult, we like to joke that they provide the test and validation for a business model rather than for a technology. And this can take many forms. So they support market analysis and commercialization roadmaps for new technologies, understanding who's going to buy them and how they might buy them, so what business model do they need to use. And they maintain really detailed bottom-up LCOE models to understand the impact that a technology might have on the overall cost of energy. And they do a lot of work as well feeding into policy makers, so helping them to understand what the industry drivers are and what the right support mechanisms for the industry might be. And I'll go into talk about one specific case study of this in a little bit. But very often when a company does come along with a new technology, it's these services that tip the balance between a great technology and a great technology that's a commercial success. So one element that we try and spend a lot of time doing is to develop collaboration and engagement within the sector. So OPIN, or the Ocean Power Innovation Network, is a new Interreg Northwest Europe project we're about to kick off, along with partners from across the Interreg Northwest Europe region. And it looks to enhance collaboration and connectivity within the industry and to help cross-sector innovation and people to learn from one another. So the partners will deliver a suite of services to organizations involved in the project, and it's as much about developing clusters of innovation, supporting networks and enhancing collaboration as it is about the individual technologies. So we're going to run annual symposia to connect researchers, SMEs, RTOs and large enterprises together. There'll be a series of workshops to transfer knowledge and help stimulate cross-sector innovation. And these will be supported by a series of deep dive masterclasses. And these will be looking into specific technology challenge that the industry faces. And some of the more, the wider, slightly more kind of economic and commercialization-based challenges will lead to the creation of collaborative innovation groups who will look to solve some of these deployment issues. But this will all be underpinned by technology assessment provided through innovation vouchers as well. So another part of what we do, and it's another really important bit of what we do, is supporting the supply chain as a whole. And so this is an initiative that we're setting up and piloting in Scotland at the moment, with hopes to roll out across the UK more widely in the coming future. And it's borrowed from one of our fellow Catapult centres. So the Nuclear Advanced Manufacturing Research Centre had this scheme called Fit for Nuclear, which is designed to help supply chain companies become ready to bid for work commercially within the sector. And so we've been working with them along with other partners in Scotland to develop a complementary scheme for the offshore renewable energy industry. And so this free service is really designed to increase business excellence and business competitiveness within the supply chain and to help them win commercial contracts within the industry. So the last thing I want to talk about is some of the support we do for the whole of the marine energy sector in terms of working with government to help them understand what the benefits that the sector could bring to the economy is and what support the sector requires in order to get it over the line. So whilst the UK is a world leader in technology development for the marine energy sector, as we've already seen today, and it has a wealth of consented sites and sites in development, it does require a little bit of support to get it over the line on a commercial industrial level. And as part of the UK's industrial strategy, the government has set out 3 key tests that it requires for an energy generation technology to pass in order for it to gain support. So can it be shown to have a clear cost reduction pathway for it to reach grid parity? Can the UK have a world-leading role in it and within a sizable market as well? And does it deliver carbon emissions at a significant scale? And I think that third test has never been in any doubt for marine energy, but the first 2 are really important. And so we were commissioned to write a report looking into these issues. And in terms of the first test, this is looking at tidal stream technologies in particular. We found that deployment is probably the biggest barrier to reaching lower costs. So just by getting to a gigawatt of installed capacity, we're going to see huge reductions in cost through initial accelerated reductions, which covers economies of scale and economies of volume, and by optimizing the devices in operation. There's going to be a lot of innovation, which will drive down the cost as well. So improving the operations and maintenance of these devices and new components and new ways of putting together these devices to reduce cost. And then going back to that risk point, by showing investors that the industry has matured, the cost of capital will come down, and so that will reduce the costs as well. And so for test 2, it was all about showing what the benefits that a fully fledged marine renewable industry could have for the UK. And we found, I won't go through them in detail, but there is a huge number of companies developing technology in this area, and there's a huge supply chain of over 800 companies operating in this space. And so we found that we could probably get to a gigawatt of installed tidal stream energy by 2030 and a gigawatt of wave energy by 2040. And by the nature of this industry, it's taking place in areas that don't necessarily, in areas outside of London and the southeast. And for the UK, which has an economy incredibly dominated in this very centralised area, this is really important because it's bringing diverse and high-skilled jobs to areas that wouldn't necessarily have them. And so 50 to 60% of that gross value add and those jobs created will be in coastal areas. So just to summarize everything that I've gone over today, technology development is crucial to innovation and is a really important part of what we do. But there's much more to it than that. And so to properly and completely support innovation, we need to do more than that. And so through things like open, building collaborative networks, through the wave and tidal analysis that we've done to lobby for the correct support, and through initiatives like Fit for Offshore Renewables to support the supply chain, we're increasing the ways in which we support the industry and support innovation. Thanks very much.
Thank you, Alexander. Any immediate comments or questions for the oral catapult? None? We're getting tired. Yes, please.
Thank you very much for your presentation. I think it could be interesting to hear a bit of what is, the financial requirements that you need to, to put this in place. So, what is your annual
how are we funded?
Income? Yes, and what are the sources?
Yeah, so we operate on a very similar model to the CoLAB scheme. So we receive a third of our funding from the UK government, which at the moment is about £11 million per year. And then we leverage that with commercial work. So the tests on our wind turbine blade tests and nacelle tests, they're done on a commercial basis with companies like GE. And then lastly, all of the companies that we work with, we do so through competitively won grant funding. So Horizon 2020 and Innovate UK is the kind of national scheme in the UK, and things like that. So the core grant from the government sort of pays for the upkeep of the facilities, and then all of our support, we have to recover our costs.
I understand there's also been quite an initial investment into the older former NARIC facilities, right? And
yes, so NARIC was set up in 2000. So for those of you that don't know, the Catapult network was set up in 2013. And when the Offshore Renewable Energy Catapult was set up, we were merged with the National Renewable Energy Centre, which had been running since 2001. And so that was a huge capital investment by the UK government way back then in order to set up those facilities which were seen as being lacking in the industry.
Yeah. Okay, thank you, Alexander. Now the last speaker of today, Ricardo Morgado from Silva Matos, the only representative of the supply chain, and that has a reason. There is only a supply chain for offshore wind by now, at least in this scale. Wave energy is not quite there yet. So, please.
Thank you, Frank. Hello to everybody. It's a pleasure to be here and to share with you Isam Industries strategy. Special thanks to WavEC to invite us also. So during the day, we have been discussing here mostly the technologies, the development, and I will give you now, lastly, a vision about how to manufacture all the devices from offshore wind to wave to tidal and put them in the water. So the point of view of the manufacturer, and in our case, a heavy steel manufacturing company, as it's Isam Industries. I know that you are tired, so I will try to be as quick as possible. Your lack of questions means also that you are fully tired over the day. I will not touch base too much about the offshore market. I think we have been discussing here that it's a huge market, mainly in Europe, but also starting already activities in the United States with the first offshore wind project last year. In Asia, there is also huge development, so I think I'm not sharing with you any new. There is a huge potential in offshore wind market. Mainly Europe is the lead continent, with mainly United Kingdom as the first one on the offshore wind installation, but also Germany, Belgium, Denmark, coastfront countries with shallow waters, which was the first investments of the offshore wind. And there is a huge potential in planning stage, also already licensed to be built over next years. We all know also that distance to shore is much further, which means also bigger components, bigger foundations, bigger towers, bigger turbines, bigger wave and tidal devices also in the future. So there is a common point in all when we talk about wave, tidal, offshore wind, aquaculture, which is steel. Most of the products has a massive use of steel. And that's where Isam Industries enters as a steel manufacturer. So we all know also that there are low-tech maturity as the wave and tidal, still on the very developed phase, and I'm happy to hear today that there are some technologies moving on quite quickly. The offshore wind is the one that shows greater maturity, and of course from the point of view of the manufacturing, we are more focused on the offshore wind. Also on onshore wind, but offshore wind, which we are here to talk more about offshore. We foresee, of course, for Portugal, huge opportunities, even though we must all be aware that there are a huge market already developed and stable outside of Portugal, I think as all we know. Portugal is a very sunny and beautiful country with long coast, with some infrastructures already in place, which needs huge, in our opinion, huge investments and modifications. But we have a long tradition in steel sector. Around 25% of our exportations are coming from the steel industry, and we have also a very competitive labor industry, and with long tradition. I think in terms of theoretical speaking, I think the country is ready. In terms of infrastructures and the supply chain, we should keep moving on and prepare ourselves on a global perspective. That's our opinion. And now, how is our strategy? What we have been doing, what we are doing, and what we expect to do in the future to be better prepared to attend our clients and the challenge of this industry, again, on the global perspective. Before to start to speak about our fabrication capabilities, just to introduce you about Isam Industries. Isam Industries is part of A Silva Matos Group, which is founded in 1980, so we have more than 30 years rolling, welding, and manufacturing steel products. We operate right now 10 different fabrication facilities in the group, with more than 500 direct specialized employees working on our different facilities. How we are divided? So we are divided right now in 3 different and independent holdings or sub-holdings. One is Isam Metal, focused on the pressure vessels and also equipment for refineries, more on oil and gas side. Global Engineering is basically focused on the transportation and logistics, and Isam Industries, in which I'm here represent, is focused on wind towers, offshore foundations, and marine structures, which is the 3 segments of the market in which we operate. So when we talk about wind towers, we talk about wind towers for onshore application, but also for offshore application, having in mind that the requirements are quite different in terms of the manufacturing point of view. When we talk about offshore foundations, we have also a wide range of offshore foundations according to water, to seabed conditions, to water depths. We can start from the monopile transition piece, passing through the jacket foundation up to the floating foundations. And there is, again, a huge amount of steel, of rolled steel, in which Isam foresees also a very good opportunity for the future business. But also having a look on wave, on tidal, and aquaculture, which is a key focus on Isam industry strategies for the future. Where we are located and where we expect to build all these products. Well, we are located in Portugal, 2 serial manufacturing lines located in north and central north of Portugal in the Aveiro region, and another one located inside Lisnave shipyard, where we have a long and strategic partnership, and where we are actually building the 2 complete wind float units for the Wind Float Atlantic project, in which I believe my colleague Aaron this morning have touched base a little bit on that. Isam Industries is basically a wind tower facility. We can produce more kind of tubulars, but basically we produce roughly 14 complete tower sections every week, which means around 25,000 tons of steel processed per year in that facility. We have a quite good installed capacity in terms of machinery, not only to cutting, bending, welding, surface treatment, and all these different areas of importance when we act in this area. In that facility, we have around 130 direct people working 6 days per 24. Then we have Sem Offshore. Some of you already saw in the news. It's a big and strategic investment from Sem. We are a family-owned group, so to decide to move for such investment like that, it was a big decision of us a few years ago. And that's the answer when someone asks us if we do believe in the market. Well, that's the answer. We are just investing right now around 30 million euros in Aveiro Port North Terminal to be even more prepared to attend bigger products and bigger requirements in the future. We'll have a huge installed capacity. I would say with some security, the major installed capacity for this kind of steelworks installed in Portugal. Well, the work started in January this year. Sorry for the beginning of the movie. There is a bug. I hope it's not from the fact that the Chinese right now. But the construction work starts in January this year. That's a time-lapse video just to show you and share with you how the works have been doing and progressing. So we just have the lease for 70,000 square meters of land in Aveiro North Terminal. It's a conception agreement for the next 25 years that was signed last year with Portuguese government and Aveiro Port Authority. That's a facility where we intend to build very big components. First, being able to receive raw materials and special raw materials, special steel plates on our quayside directly, but also, of course, export final products, which can be offshore wind tower or a big tubular for an offshore application or a big structure directly from our facility to the transportation mean. I don't know if there is some music in the video, if you can put the volume a bit on. If it doesn't work, okay. No music. Or if not. Frank, you need to give me five minutes more because the videos I have a justification. Well, we'll have also a special surface treatment workshop, which is the third one, in which we'll be able to not only blast but also metallize and paint all the products on the special cabins with 12 meters per 12 meters per 52 meters long. Also, in terms of unit weight, we'll be able to lift up to 450 tons each unit inside the facility with the overcranes. And we'll have, and today we just shared this in the news, we'll have a special developed welding technology in which we have been working directly with our welding technology supplier. So we expect to be very well equipped, again, to bring competitiveness, to bring costs down, because that's the major point right now on the offshore wind industry, and to serve better our clients. So that's the current state. We expect to open officially by March next year. Right now we are already in the receiving heavy machinery, doing the first installation and then pass through the commissioning. And that's the aspect inside. So moving on and talk about our third fabrication site called ISM Marine. ISM Marine is located inside Lisnave shipyard. As you may know, some of you, Lisnave was a shipbuilding yard up to 15 years ago, 15, 20 years ago. Then they quit to do ship construction. They are much focused on ship repair over the last years with a very stable business, but they just abandoned around 500,000 square meters of the yard, where ISM operated back in 2011 when we built the first wind float, the full-scale prototype. So after this success story, it was, I would say, the common sense to move and to set up the strategic partnership with Lisnave, where last year we have invested inside that wide workshop, creating the best capacities to attend the current project that we are building now, but also future projects. And this site gives us a certain level of flexibility to integrate more labor, more steel constructions, and create more value to our clients as well. Regarding products we made and some projects that we have been made, so that's not so different for you. That's typical wind towers that we have been made since more than 12 years on the serial and stable activity. We have been supplying roughly more than 4,800 tower sections worldwide since we start, mainly to Europe, but also to South America and Central America and North America. That's also tubulars for offshore application. Well, in 2011, as I told you before, we have been challenged to build the first full-scale prototype of the wind float. It was a very important project for us, in which we performed it in Lisnave back in 2011. Here is a small video about the construction time-lapse. I believe most of you maybe already saw it, but anyhow, it's again, I think it's a nice movie to show that also there is some good capacities, the need flexibility and the need ambition to make also very big things in Portugal, not only outside of Portugal, of course. This was in October 2011, and it deployed a 2 megawatt wind turbine. No music also, so sorry for that. We are on that time we were also able to make together, of course, this installation was made together with Principal Power. We were investors, we were able to manage all the turbine installation inside the dry dock in Lisnave. With the project that we are running now, Wind Float Atlantic, there is no way to do this kind of operation, because as you may know, the turbine output will be much bigger, so which means that turbine weights and dimension, but also blades and towers will be much bigger than this one. Then it was talked up to Aguçadora test site, where it was performing during almost 5 years with great results. And that's, well, we usually say that the good son returns home, and that's what's happened with that wind float that you just showed. We just saw the video before. This year, the wind float arrives again to Lisnave. The challenge was, okay, there is music now. The challenge was to put him again inside the dry dock, make all the retrofit works, repair works, replacement of equipment, coating works, prepare it to be given another uses, which is being now producing electricity in Scotland, and will give space for another pre-commercial project using wind float technology in the coming years. So this was arriving to Setúbal Bay. It was picked up in Sines port, targeted to Lisnave. It was a very challenging operation, as you may understand. again being made under strict cooperation with Principal Power, engineering and technicians, with Lisnave, but with lots of Portuguese companies that were supporting us directly on the ground, and this I think is good to highlight. That's also the beauty of the floating foundations. We can always bring it up again to the dry dock or to a quayside to do repair works, retrofit works, adaptation works, whatever we need. After stabilizing it in the dry dock, well, we start all the works. It was inside the dry dock facility more than 30 days. We were doing different works in parallel, not only repair, but also replacing already new equipment and making a lot of different activities, running against time, of course, because time is money on this industry, and the end client was waiting the foundation to start to support wind turbine to inject electricity in the grid, because again, at the end of the day, money talks, always. Then we position again to bring it out, mainly, of course, with again a combination with the Dockmaster of Lisnave, the tides, port authorities of Setúbal. It was quite different stakeholders involved in this operation. Mainly this one that you will see right now, because now it's to put the wind float off and make sure it can be transported, in that case, up to Scotland. Special word also to Renewable, which was the talk company that makes also a good job, a very flexible job. Then we got Albatross, a semi-submersible barge coming from Norway that was contracted to transport it to Scotland on the dry transport. Well, now it's official. It already produces not the wind float, of course, but the turbine installed on top electricity in Scotland, and it was a success. So that's the main point, was to deliver on time and to be able to be used for another project. To finalize, only Frank, sorry, and thank you again. That's only a few pictures about the wind float Atlantic. We are building now at Lisnave. We are building 2 complete foundations. I would love to show you much more pictures because the works are much more advanced, but for intellectual propriety and confidentiality, as you may understand, we cannot reveal more. It's going. It's a very challenging project for us, but it's moving right now. Just to end up and saying thank you for your attention, and I hope you enjoyed the presentation. Thank you.
Yeah, thank you, Ricardo. There was some fascinating pictures. Before passing to the audience, I have one question in 3 parts. Your capacity in the Lisnave, how high would that be per year? How many platforms could you build? And how many do you actually expect, or do you find realistic to build in the next, say, 5 years? And would you have a plan B or C geographically near if you suddenly have to build 10 or 20 per year?
Yeah, that's the million-dollar question, I would say, right now in all the industry, because, well, now floating foundation starts to be more mature in terms of being used to project development, and mainly in UK, but also in France and other countries in Europe with more mature in this market are already raising the 50 units a year, 30 units a year, because that's the only way to achieve commercially and to drive costs down. To answer your question directly, right now, there is no big capacity in Portugal, but also in Europe, to build, I would say, in 1 year, even 20 or 30 wind floats at all. ISCM right now, depending on the specific kind of foundation, because wind float is a technology that can be adapted, we would be able to produce maximum 2 in 1 year. However, with a very important point, when we said produce, we are assuming, as we are doing right now in this project, to do all the fabrication works, also the assembly works. And in our opinion, it's clear that if we achieve the commercial scale on this market, and if we need to bring more units per year, we need to combine capacities, not only even on the national level, but on the international level, on the European level, if we are talking about Europe, where we should have clearly the serial fabrication in one side, the serial assembly works in other side, because one thing is to make the pieces of the puzzle, other thing is to put all the pieces together and bring it out. And in the middle, the key point, which is logistics in all this, because all this means transports, means load-out operations at the end. So yes, we do see possibility. In the future, with this kind of organization, no, we do not have any capacity right now to think about scalability and several units a year.
But you would expect you have the required warning time to be prepared for that?
Yes, of course.
For example, if Windfloat Atlantic is a huge success, then
yes,
suddenly...
if the project is a huge success, as we all expect, well, our position is to be more, depending on the project location, but to be more on the fabrication serial way, as we are not an assembly company, but a heavy steel fabricator company. And even for some of you might be all the same, it's not at all. It's different ways, different machinery, different kind of approaches. We do foresee, and that's why also, and not only for this, of course, but that's why also we are strongly invest, and over the last 3 years, we just invest in Lisnave and we invest in Aveiro, is to create a kind of the offshore renewable hub from Portugal to every world or every place in which we can be competitive, of course.
Very good. Yeah, please.
But then when I listened to you, I got another one. So I'm going to ask 2 questions. And the one that occurred to me was, you mentioned that in this case, the new project, you cannot put together all the system in the yard. So you cannot put the turbines in the yard. You have to do that elsewhere. I didn't understand very well, so that's why I'm asking this question. And the second one was different. You come a long way as a company, so you had to learn a lot of new skills, and you have to acquire a lot of new competencies. And I've read somewhere that you have had some difficulties recently to get people with the skills for the new expansion of capacity. So could you expand something about that? What did you do to learn the new areas, and how do you plan to address this problem of the skills necessary for the future?
Good. Okay, so first question, when I said the limitation on the dry dock, which means that first wind float, the dimensions of the floater together with the dimension of the tower, the nacelle and the 3 blades were fitted below the gantry crane of Lisnave, as you saw. So it was easy to use already the gantry crane and do all that movementations with the wind float stable inside the dry dock. When I say that there is no way possible anymore, is that because now we are moving for a pre-commercial project. So when we were talking about the 2 megawatts turbine on the 2011, we are talking now about 8+ megawatts turbine, which means that the nacelle is much bigger, which consequently means that the tower is much higher, the blades are much bigger, so no more space to use the gantry crane, which means that these foundations that we are building will be delivered to our client in the port facility, on the quay side with deep waters, where the big turbines, blades and towers will be there with a big crane to do all the installation and the decommissioning. Hope it clarifies. Second question, it's you raise, in our opinion, the key point on all that, because I can be showing you facilities, industrial halls, but at the end, if there is no people inside, we do zero at the end of the day. Skills is a very key point, not only for the steel industry, but I would say for the overall manufacturing industry, not only in Portugal, but in Europe and outside. Just here a few weeks ago that the average of a steel worker in the United States is 56 years old, and the one that shows this told me that in Europe it's more or less the same, which means that there is a lack of specialized labor. How we do see this? So it's to move one step ahead. If there is no enough facilities, or at least willingness for the young generation to go and to learn, in our case welding, well, we make the school at our facilities and we bring the people there, and that's what we made at the beginning of this year. We create a welding school inside. We are bringing some welders, not every week of course, but in each period of time, and in parallel we open since several months a very strong recruitment process, in which we have been having some successes, but I should be honest with some challenges to find out the right skills, then the experience skills. It's not easier right now for a steel company, as I would say for any other companies working on the manufacturing side in Portugal and in Europe. But that's something that we should overcome with labor. Also in putting in a little bit of automation in our lines, which is also a key point, but having in mind that without specialized labor we do not do anything that I was showing here today.
And local